exploring algorithmic bias reinforcement, a socioinformatics perspective.
Welcome to the Universal Principles podcast. Today we're diving into algorithmic bias reinforcement. In a nutshell, it's how algorithms trained on biased data can make existing inequalities even worse. Sounds scary? It can be. We have a special guest with us today to shed some light on this important principle. Welcome.
Thanks for having me. I'm excited to be here. Algorithmic bias reinforcement is a critical concept, especially within socioinformatics, which is the study of social phenomena through the lens of data and computation. What's fascinating is how feedback loops between data, the models we build, and real-world outcomes can unintentionally amplify biases and lead to systemic discrimination. It's like a snowball rolling downhill, gathering more and more snow, or, in this case, bias.
So it's not just that the bias exists, but that the algorithm actively makes it worse. Could you walk us through a concrete example of algorithmic bias reinforcement in action?
Absolutely. Take facial recognition software. Many of these systems were initially trained predominantly on images of white faces. Consequently, they often perform poorly when identifying faces of color, leading to misidentification. Another example is predictive policing. Algorithms trained on historical crime data might disproportionately target marginalized communities, reinforcing existing biases in the criminal justice system. These examples highlight how biased input leads to biased output and perpetuated inequalities.
Wow, those are some pretty heavy examples. It's almost like the algorithm is learning the wrong lessons. Can you give us another example?
Sure, think about hiring algorithms. If a company's past hiring practices were biased towards, say, male candidates, an algorithm trained on that historical data will likely perpetuate that gender bias, leading to fewer women being hired. The algorithm isn't inherently sexist, but it's learning and amplifying existing patterns, even if those patterns are unfair.
So what you're saying is that garbage in equals garbage amplified. It's pretty concerning when you think about all the areas where algorithms are now making decisions. Are there similar principles in other fields, something that works like this?
Definitely. In digital sociology, the concept of echo chambers mirrors this. People tend to congregate in online spaces where their existing beliefs are reinforced, leading to polarization and a lack of exposure to diverse perspectives. It's the same principle at play. Initial biases are amplified through feedback loops.
That makes perfect sense. So what can we do about algorithmic bias reinforcement? How can we stop this snowball effect?
Great question. First, we need to prioritize diverse and representative data sets during algorithm training. Second, we should implement regular audits to assess algorithms for bias and fairness. We need to hold these systems accountable. Third, it's important to develop transparent algorithms that allow users to understand how decisions are being made. Black boxes don't help anyone.
Those are some great practical steps. So diversity in data, regular audits, and transparency. Easy to say, maybe harder to do, but definitely worth striving for. Any final thoughts on algorithmic bias reinforcement before we wrap up?
Just that awareness is key. We need to be conscious of the potential for bias in algorithms and actively work to mitigate it. Our digital future depends on it. If we are not careful, we risk automating discrimination at scale.
Absolutely. Well, this has been incredibly insightful. Thanks so much for joining us on the Universal Principles podcast. This is definitely something to ponder. Make sure to tune in next week. We will be discussing